Chapter 8, Consumer Mathematics. 8.5, Amortized Loans. Calculate the payment to pay off an amortized loan. Construct an amortization schedule. Find the present value of an annuity. Calculate the benefit of refinancing a loan. Amortization. The process of paying off a loan plus interest by making a series of regular equal payments is called amortization, and such a loan is called an amortized loan. Formula for finding payments on an amortized loan. Assume that you borrow an amount P, which you will repay by taking out an amortized loan. You will be making M periodic payments per year for N total payments, and the annual interest rate is R. Then you can find your payments by solving for R. Example, determining the payments on an amortized loan. Assume that you have taken out an amortized loan for $10,000 to buy a new car. The yearly interest rate is 18%, and you have agreed to pay off the loan in 4 years. What is your monthly payment? Solution. We'll use the preceding equation. The values of the variable in this equation are P equals 10,000, N equals 12 months times 4 years, or 48 months. R over M is the annual interest rate divided by the number of payments per year. 18% divided by 12 is 0.015. We must solve for R in the equation. We have the amount of the loan times 1 plus the interest rate, the monthly interest rate, R divided by M, raised to the power of the number of payments, 48, which equals R times the quantity, 1 plus that monthly interest rate, raised to the power of the number of payments minus 1, divided by that monthly interest rate. If we calculate the numerical expression on both sides of this equation, we get 20,434.78289 equals R times 69.56521929. Therefore, your monthly payments is R equals 20,434.78289 divided by 69.56521929, which is approximately equal to $293.75. Example, constructing an amortization schedule. The Cullen family wishes to borrow $200,000 to finance a new summer house. They have obtained a 30-year mortgage at an annual interest rate of 6%, which has a monthly payment of $1,199.10. Construct an amortization schedule for the first 3 payments on this loan. First payment. At the end of the first month, the Cullens have borrowed $200,000 for 1 month at a monthly interest rate of 6 divided by 12%, which we write as 0.005. So, from this simple interest formula, the interest they owe is 200,000 times 0.005 times 1 for $1,000. The monthly payment is $1,199.10. So $199.10 is applied toward the principal, and the balance is now $199,800.90. Second payment. The interest for the second month is $199,800.90 times 0.005 times 1, the monthly interest rate times 1, which is $999. So taking that out of your payment, $210 goes toward the principal. The table shows the schedule for the first 3 months. Now, on the third month, we have a monthly payment of $1,199, just like the previous months. The interest is calculated on the previous balance, $199,600.80, which means they owe $998 on interest. Taking that out of the monthly payment, we are left with $201.10 that can be applied to the balance, bringing the balance down to $199,399.70. So as you keep making payments, the amount paid toward interest decreases and the amount of your monthly payment that goes toward principal increases. So the longer you pay your loan, the more of your payment goes toward principal. If we know the monthly payment and the interest rate and the number of payments, then the amount we can borrow is called the present value of the annuity. Finding the present value of an annuity. Assume that you are making M periodic payments per year for N total payments into an annuity that pays an annual interest rate of R. Also assume that each of your payments is R. Then to find the present value of your annuity, solve for P in the equation, the annuity, the amortization equation, where we have the annuity on one side, the right-hand side, and we have compound interest on the left-hand side. So those are both future values that equal to each other. And we call this the amortization loan formula. Determining the price you can afford for a car. If you can afford to spend $200 each month on a car payment and the bank offers you a 4-year loan with an annual interest rate of 12%, what is the present value of this annuity? Or what is the purchase price of the car you can afford? Solution. Use the formula for finding payments on an amortized loan. We know R equals 200. Little r divided by m is 1%, or 0.01, and n equals 48 months for 4 years. If we substitute these values for the variables in the equation, we get the following. Calculating the numerical expression on both sides of the equation gives us P times 1.612226078 equals 12,244.52155. Now dividing both sides of this equation by 1.6122226078, we find that P equals 12,244.52155 divided by 1.6122226075 is approximately equal to $7,594.79. You may find this answer surprising, but the mathematics of this problem are clear. If you can only afford payments of $200 per month, then you can only afford to finance a car of about $7,600. Suppose that you have $20,000 remaining on your student loan with an interest rate of 10%. You wish to pay off the loan in 10 years. Assume that you can refinance your loan at 4%. A, what are your monthly payments of your original loan? B, how much will your new monthly payments be? C, how much interest will you save over the 10 years? We see that the monthly payments on a 10-year loan for $1,000 at an annual interest rate of 10% are $13.22. So the monthly payments for a $20,000 loan are 20 times $13.22 for $264.40. B, if you refinance, you are taking out a 10-year loan for $20,000 at an annual interest rate of 4%. Using the table, we see that the monthly payments on $1,000 is $10.12. So your monthly payment will be 20 times $10.12 for a monthly payment of $202.40. Part C. If you continue making payments according to the original loan at $264.40 for 10 years or 120 months, you will pay a total of $31,728. If instead you make payments of $202.40, you will pay a total of $24,288. The difference of $7,440 is the amount that you will save on interest in refinancing your student loan.